Assalamualaikum. My name is Yana Ishtiaq. I'm a mechatronics engineering student, and today I'll be explaining a project that I made using MATLAB. This is a project that I made for my machine vision course, and we were required to segment a video. I'll be explaining it in this live script so that we can work as we look at our results. Okay, all right, over here, as you can see, I've played this video. So it has these two lanes and cars in dark and lighter colors are passing by. There's this pole, which is a noise, kind of a noise. We have to subtract it when we'll be working on it. Other than that, there's also this salt and pepper noise in the frame. This is an RGB video. Over here, it shows that it's running on 10 FPS, 10 frames per second. So as there are 240 frames right over here, it means that it runs in 24 seconds. Okay, so moving on, what we need to do is we need to segment the cars and we have to draw bounding boxes around them. And we have to create such a mask which detects both the light and dark colored cars. So we have to use some kind of thresholding which is inclusive of both light and dark colors. Other than that, we also have to address the pole, which literally splits the cars passing by. And then we also have to compute the number of cars within each frame, the mean region and the total number, the total region area in one frame. There are 240 frames, so this is how we'll be working. First, we'll load the video, and we will load its frames one by one. Then we will remove noise. Other than that, we have to convert it into grayscale. Then we'll be creating some mask using some segmentation techniques. Then we'll apply the mask on our frames one by one. After we have obtained a masked binary image, we'll use region properties. After that, we'll be saving our video frame by frame. Okay, so the first step is to clear all our workspace over here. It's important to do that so that your videos and your frames don't get mixed up. Okay, there we go. Our workspace is clean now. All right. After that, I'll be loading the video that I need to work on that I just showed you guys above. It's the road traffic video. I've provided a path over here. So what you can do is you can also add your folder over here. You can navigate your MATLAB to that folder that you're working on. Okay, so let me run it. I'll click on the blue line over here. Okay, it loads all the general properties. Video reader is another function that I'm using over here. It tells me what the duration is, the number of frames, the general information, what's the format of the image, how many pixels does it have, the frame rate, all the necessary information that I might need. Now I'll provide a path to the folder that I want my processed video to say that. So the name of my video is going to be segmented traffic video. Since I've worked on a lot of others, so I'm just naming these. You can name it whatever you want. Just don't forget to add the .mp4. Just don't forget to add the .mp4 extension at the end. Okay, and I'll make sure that the frame rate of my output video is the same as the frame rate of my input video that I've saved over here. You can hover over it to look at its properties. Okay, and then I'll be opening my output video so that I can work on it and save frames in it. This is important. You have to do this in the beginning so that you can process and load your images within your output object. Okay, after that, I also need to save some data of every frame. So I'll be using this results table variable, which is just basically a table of 3 rows, 3 columns. Okay, this is the type double, and then here are my variable names, number of cars, the mean region area, and the total region size. Let me run it as well. Okay, wait, I didn't run this. Let me run it, and then I'll run this one. Okay, so as you can see, our workspace is starting to get crowded over here. I have an object, I have this table initialized, and I also have my input Okay, next up. Okay, so the technique that I'm using is based on moving objects. So I won't be detecting using any complex techniques. What I'll do is I'll take a reference frame and then I'll compare that reference frame with other subsequent frames, and I'll just subtract the moving car area along, like from the original reference, and it'll give me the car area that I want, and then I can apply binarization and other techniques on it. So for the first frame, I'll be reading the frame using this read frame function over here. If you want to find out anything about a function, you can simply right-click on it, press on help, and then you can look at its documentation. This just reads the next video frame. We'll just read the first frame, and we'll apply this enhancement function on it. Let's look at this enhanced single frame color function that I've created right over here. Sorry, it's not this one, it's this one. This is the one that I created previously. It also converted it into grayscale, but since I want my video to be sharpened within the RGB, so I'll use this enhance single frame colored function. What this does is for R, G, and B, which are the red, green, blue channels, it runs an enhancement pre-processing, image pre-processing methodology or functioning on it. Okay, first I create a variable which is the same as the input frame. So I'll be initializing it over here using the like of zeros function. Okay, so this is the size of my input. Okay, moving on, for all the three channels, I am using a for loop over here. So it will first run at the R and then the G and then the B channel. What it will do is it will take a frame from that channel, then it will apply a median filter on it of this size. After that, it will sharpen the frame using IM sharpen by this amount. Now I computed these amounts by, varying the values for both of these and checking out which frame suited me. So you have to figure out your own values for both of these, to see which values go best for you. And after that, I'll just simply save my sharpened frame, my processed frame to my enhanced frame, and then I'll just return it. It'll be returned over here. So back to our main segmentation file. Okay, so first I read the frame, then I applied this function on it, which cleaned the RGB frames for me. Okay, and then I'll be making sure to save the first frame in my original video that I have opened previously. Okay. Let me show you guys what it looks like. We're sure that the frame we're saving is correct. So this is what my frame looks like. I thought that it looked best, so I continued with it. Okay, for saving the background, first I'll convert my frame into grayscale, and then I'll be converting it to double. So here is what my grayscale background looks like. This is my reference, all right? Okay, now moving on, in order to apply all these processing techniques and figuring out segmentation, I'll be reading all of my next frames in a while loop. But for now, I have commented it so that we can understand what exactly is happening in every frame. Okay, so let's look at one frame. I'm applying the same enhanced single frame color to my next frame, which will be the second frame now, because my first frame has been read. All right, and it has been written on my output object. Okay, I'll save this variable by the name img so that later on when I want to append it to my output video, I don't have to convert it back to RGB. Okay, then I'll convert my frame to gray so that I can process it further. And here is my second frame. Okay, I'll be running this portion of my code several times so that you guys can see a car in our frame. Let me keep running it. We've already saved our background. Okay, there you go. Cars have started to appear. There we go. We have two white cars passing by. Moving on. Now I'll be extracting the moving cars from the frames, and I'll be using simple background subtraction over here. So I had a reference background which didn't have any cars in it, and now I have a frame which has cars in it. So what do you think is supposed to happen? Let us see. Okay, so what happened was that the cars, the area that they're above on, it got, like, other than that, everything got subtracted. So everything else was in common except these regions where the cars are located. Now we'll be applying some segmentation techniques. We'll be cleaning this image and we'll be applying some morphological operations on it. So you can use a lot of apps that you can find over here. There's like batch processors and image segmenters and color thresholders and whatnot. But I'll be using the image segmenter over here. I can call it by just writing down image segmenter and clicking on this. It will open up the segmentation app for me. So this is my segmentation app. What I will do is I will load my image, which is my frame diff image, and then I will choose not to increase the contrast so that my other images that do not have cars don't get messed up with. I'll be applying manual thresholding, not global, a manual threshold, right? All images are kind of similar due to the subtraction. We don't have that light or dark colored car problem. Let me select a threshold in which only my car is highlighted and I don't have a lot of noise. I have this noise because the camera was not static, ideally. So that's why we have these little blue dots. Show you its binary mask. This is what it looks like. Let me create it. It's not perfect, but something. Okay, next I will apply morphology on it. What morphology does is it smooths your image out using different structuring elements. And you can apply different masks over here. First, I should get rid of these, the noises, because my articles are, yes, these noises. So let me erode it first. And I don't want to erode it that much. So I'll be using a disk-shaped structuring element. Disk seems the most logical, so let me go with disk. Okay, let me apply it. I can simply use closing on it. Let me increase the radius. Like that. Apply it. Let me erode it. Okay, that's better. Maybe reduce. Okay, and then I'll apply it. Okay, this looks better as compared to our original images, like the original cars. Okay, from here, I have applied morphology and I have also applied a segmentation technique, binarization technique, and now I can generate its function. So you click on export and then you generate the function, and here I have a function. So it's just written down everything for you that you did in the app. So first we did manual thresholding, then we applied erosion, and then closing, and then erosion again, and then it masked the image. All right, so the issue is there's like a serious issue over here. It's important that you try out making these masks and applying them to all of your frames, because for instance, if you have a frame which has a pole in front of it and your car is splitting into two, then you will need to change your mask. For instance, using the image batch processor over here, I applied a few functions that I made using the image segmenter. And here are some of the frames. Like, you can see the pole, it distributes your car into 3 or 2 regions, which you don't want happening. So your car, it just gets, split into 2. So in order to address this, what we should do is apply segmentation on a frame which has a pole in it. Which has a car being split by a pole. So let me go back to my live script. I'll go up and Right over here where we are reading frames, I'll try to get a frame where we can get a frame where the car is being split. Let me run it once again and once again. Okay, that's a good enough frame. Let me move forward. Apply background subtraction on it. And now I will open it. Let me load image from my workspace. And yes, I want to continue with my frame depth. No. Okay, you need to say no so that it doesn't improve the contrast of every image. I made that mistake of applying the contrasting, adjusting, and this is what it gave me. It adjusted every frame. So for every frame where there was no car, it turned all white, which looks hideous. See, as soon as the car goes and it turns white, it looks bad. I don't want that. Okay, moving on. Okay, let me apply thresholding on it once again. Okay, this is good enough. Okay, now here I'll be applying dilate function. But first, I think I should need to get rid of the noise, so let me erode it. Oh, that is too much. Okay, so most of the noise has gone, and I'll apply this. I like this. Now I'll apply the dilate function, and what I'll do is I'll use the rectangle one so that we can fill this gap because of the pole. Okay, I'll use the rectangle function. Let me increase the width. This will require me to increase the width a lot. Let me try 40. Okay, 40 looks good. 45 to be on the safe side. Apply it. Okay, use some other structuring element. So you have to like try out different masking options, different morphology options, and see which one suits you best. I need to cover up the gap in between. Let me check what works. There you go, octagon works best in our case. Let me apply that. The cars are way too big, so let me erode it somewhat. Okay, that looks better. The width is huge. There we go. Let me apply it. Close the morphology. Let's look at the original car. Okay, so this is the original car and it fits kind of perfectly. So that's what we need. Okay, now I'll be exporting this function and I'll be saving it as segment image. Save. Okay, and let me copy the name. Okay, in my live script, let me comment it out. And now I'll be applying the mask. Let me apply the mask that I made over here. Okay. So the function returns us a BW mask. This is a variable that we don't need. So we put an apostrophe over here. And let me run it for other frames as well so that we can confirm it runs best. Like I said, you can use the batch processor. That works best if you want to check out all your other frames. Let me run it. There you go, beautiful. Let me run it on some other frames. Maybe with this car splitting. Okay, it got split. Let me see what the results are. There we go. Okay, so it did try to bridge the gap, but not that much. And let's move on. Okay, so now the sixth step is to calculate the region properties. What we'll be using is the region props function. By this function, you can obtain bounding box information or the area information. There are lots of other labels that you can obtain from it. Just click on help. Okay, so there we go. We can get area, centroid, bounding box. It's all listed over here. Let me make it bigger. Circularity and all of these. We only need to know the area. So that's all that we'll be doing. Okay, so bounding box and area. So the number of cars will be the number of regions that it returns. So numerical elements, how many are there in this stats object. And then it will calculate the mean region size using mean and sum. stats.area, we have a stats named object over here. Let me run it. It's run, and you can see right over here, it's a structure. Because I've created a variable over here, and what it does is it saves my image. Like my frame that I enhanced previously, it's not in grayscale. It says over here, this is the length, width, and the channel, so it's RGB. Okay, so it's saved over here in car box, and I'll be applying my bounding box on this variable. Okay, moving on. So I may have more than one cars in a single frame, so I'll be applying a for loop, which will run for number of car times. Okay, I'll obtain the bounding box information in bbox, and then I'll insert a shape, a rectangular shape on my car box, which will be of red color, and I've given its width over here. All right, the rectangle dimensions are the bounding box, and this is my input. So this will create boxes on my RGB image. Next up, I'll append my results to my results table that I previously initialized. My new entry over here, all the variables that we calculated, and then we'll be appending. As you can see, we have successfully drawn boxes around our moving cars. Okay, and then you can simply display your results using disk. So there are three number of cars. This is the mean region, and this is the total region size. Okay, next up, we'll save the frame, and this we have to do in every iteration of the loop. As I mentioned before, we're just running this for singular frame. So I'll save it, and after that you have to close your video. Okay, so as right now we only have 2 frames. This is everything that it'll show us. Okay, in order to build your whole video, you'll have to run the while loop over here, and I've done that in my other file. This is the M file. I have initialized everything over here. Let me run this section wise. Okay, so we're doing the same things that we were doing before. I've just changed the name this time. Okay, now I have used a while loop, which will run for how many frames there are. So it will run 240 times until we reach the last frame. And it ends over here. And I've put my enhancement image pre-processing, its grayscale conversion, my background subtraction, so my segmentation mask, and after that I'm calculating the data that I need by using region props. Then I'm applying the bounding boxes on my image. Then I'm saving the results to my table, and then I'm just writing every single frame to my output object. So let me run it. It's busy and it's running. You can check your command video to see if there are no issues. So it says no video frames were into this file. The file may be loaded. Okay, let me change my file name. Let me make it 8. Okay, let me run this once again. It says busy. Okay, it didn't give any error this time. Let me run it again. Okay, it's still busy, so it's running. Still busy. It's 240 frames, so it will take time. Okay, it's run. Let us look at our workspace. Our workspace just got cluttered. Okay, so this is our result table. It has 239 values. I think I didn't save the first frame, so it doesn't have the first frame's values, but it has all the other saved. You can double click on this. So as you can see, this shows for every frame how the cars are increasing. So in the fourth frame, we have 2 cars, and then they increase to 3, and then they lessen to 2, and then 1. Then we have frames where there are no cars, so there is no mean region. Moving on, we have single frames, and then 2 frames. I think these are some minor errors that we encounter. So like there are minor errors. You can try out different functions, different techniques, and maybe then these errors will go away. Anyhow, it shows quite good results. Let us look at the video now. Okay, I didn't close my video, so let me run this last section, which will save all my results in an Excel file, and it will close my video, and then it will also play my video. It's 8. Okay, so let me run this section. There we go. This is our segmented video. It runs and you can see all the frames are segmented. You can notice all the cars, even the pole is being addressed. So the pole issue, it doesn't create two cars, but one. See, it seems that it's working for bigger cars, but for smaller cars, it is somewhat erratic. Other than that, our cars are also merging. We can use some complex techniques to overcome that issue. Or maybe some other segmentations. So this is everything. Thank you for watching.